About a few months ago, I had to give a talk to the Chemical Research Society. I think it is in Guwahati or Bagdogra, I don't remember which place it was. So I prepared a talk of this kind, and we thought that something like that we should give such a talk to our own students and possibly even teachers. You know, the amazing thing about chemistry, with which I have lived for a very long time now, I have lived with it nearly 60 and odd years, 65 to 66 years. It has been a wonderful life for me. But unfortunately, what the sad thing about the subject is, even chemists who work in that field don't understand what a fantastic subject they are working in, because they know little about anything other than their own little small area of research. But chemistry has a much bigger background, much bigger history, much greater history than many realize. Unfortunately, in school, college, or even during PhD days, very few people even talk about the history of chemistry, not as a subject, but just give them an inspiring, some introduction to how chemistry came about. Yeah. That was my habit as a teacher in IIT. Never allowed anyone to enter once I started the class. It disturbs me a lot. So, okay. Okay, I was just telling you this background of why I thought this talk could be worthwhile. So those who know everything about history of chemistry and stories of chemistry, there is nothing new. For those who don't know, there may be something to hear. Those who are not chemists, at least you will consider that it's not a bad subject to work in. And the story is exciting for various reasons. I will show you why. Well, if you remember, what happened to this? In 2011, we did not celebrate a very important centenary. 1911 was when Rutherford gave the structure of the atom. I don't think there is anything much more fundamental, important in history of science, engineering, everything put together than that discovery. But nobody celebrated it. I wrote to many people, including in India, including the physics associate, nobody thought it was important enough. However, in 2016, just the year that last year, we celebrated another major thing, which is fundamental to everything one does in chemistry and everything one does in biology, everything one does with life, namely the chemical bond. If the concept of chemical bond didn't exist, there would be nothing left in this world. It is all because of the chemical bond we live in this world. And now, atomic structure, this is the picture of Rutherford. I just start with some old pictures so that you remember who Rutherford is. This is something which every school child should see. He is, next to him are Cockcroft and Walton, who worked under him and made the first atom smashing machine, the Van de Graaff generator. And those of us who work in Cambridge are very familiar with this laboratory where Rutherford did this. And now everyone in physics, chemistry, doesn't matter. When you think of an atom, you think of Rutherford atom. Of course, it's wrong. Rutherford atom is not correct. But we think of only the nucleus in the center, electrons around, that old Rutherford atom that is there permanently in the minds of people. But correctness is not important. That picture is so appealing that it is difficult to get rid of it, however incorrect it may be. Now, this Rutherford was somebody who didn't like chemistry. He used to like chemistry is nothing but collecting stamps. But as luck could have it, that is why there is God, you see, because he got a Nobel Prize in chemistry. He didn't get in physics. He got Nobel Prize in chemistry for his investigation to the disintegration of elements and the chemistry of radioactive substances. Just because there are a lot of young people, I have changed the subject a little bit to tell you something about this young man at that time. In 1895, for the first time in the history of the University of Cambridge, foreign students were allowed to do PhD. Not only that, if you had to do PhD in Cambridge, you had to have an undergraduate degree from there. If you are not a BA from Cambridge, you couldn't do PhD there. But the first exception made in 1885 was this young man from New Zealand. How luck and chance really decide many things in life. Just when he came, he found J.J. Thomson in physics department trying to discover the electron. And so he enters a lab in Cavendish where electron was just about to be discovered. with a professor who was at his prime at that time. Of course, soon he takes over and corrects Thomson. Thomson's model of the atom was wrong. He corrects him. But in the meantime, you remember 1895 to here, exactly 13 years after he started his PhD work, he got a Nobel Prize. It is amazing. And of course, the 1911 discovery was after this. And because another part of history today, I'm not going to talk about it. He stopped doing research himself after that. He encouraged so many people to come to the laboratory and do things, and do many things at that time. Well, 2011, in fact, for those who may not know, Chadwick, Kraft-Walton, Kapitza, the number of the number of people who came to the laboratory, most of them ended up getting a Nobel Prize, is unbelievable. His story was, Rutherford took pride in all those students. In fact, Niels Bohr always referred to Rutherford as my great master. He didn't even address him by his name, I believe. He used to call him sir all the time. Okay, he was such a man, a great teacher who took pride in young people all his life. And this is also 2011. The reason I'm showing it is how great things have happened so long ago. This is the discovery of superconductivity by Kamerlingh Onnes in Netherlands, and this is his teacher. This is Kamerlingh Onnes with his teacher van der Waals in 1911, and this is another classic picture. We didn't celebrate the centenary of superconductivity. A lot of people tried all over the world. Somehow it was not taken up. It was a great thing. Well, this is the famous discovery of superconductivity of mercury at 4.2 Kelvin by Kamerlingh Onnes. That, of course, he got a Nobel Prize for that work. I have not yet started my lecture on chemistry, but this is the picture I used to give to all my in my tutorial in IIT Kanpur. The first year undergraduates. They were supposed to identify the names of people in this picture. They get as many marks as the number of people they identified. Because that was not an exam, but that we added to their grades actually, which is not a real exam. Well, of course, I hope you identify all the people here. And if you don't know, and that is, well, I taught here Madame Curie here, and many others, and Rutherford, Planck. Who is this man standing? Einstein. See, Einstein then was not important. I always tell them, so that he still stand there. Einstein was not as famous in 1911. That was the first Solvay conference. In the history of science, the reason I started the lecture with this is to give you a background of chemistry, for chemistry later. 1911, imagine. At that period, if you invited all the great scientists of the world, there will be about 20 or 30 in number. Today you can never do that. There will be several thousand people who will come for such a conference. And this is a famous picture. I will show you the fifth Solvay conference. This is everybody sitting, you can see Einstein is in the center by that time. And Madame Curie is here. And Niels Bohr is there, you see. And I hope you see that young boy. We know, very young. Who is that? Heisenberg. And you see, Heisenberg is another story for young people. At the age of 22, he makes his famous discovery of the uncertainty principle. And that too he did when Niels Bohr went on a holiday in August. When he came back, he tells Professor Niels Bohr, when you were absent, I made this discovery. He said, why don't you tell me? Let's discuss it. Yeah, unfortunately, I've already sent it for publication. And he said, you couldn't wait for 3 weeks. Said, yeah, but it is such an important thing, I thought I must send it off for publication. And that is Heisenberg. Okay. And this, just to remind you of the Solvay conference. And 2011, was also something we all celebrated all over the world. It was because of the centenary of the second Nobel Prize of Madame Curie. She got the second Nobel Prize for the, in Nobel Prize in chemistry. The earlier one was in physics. And of course, she suffered a lot in life. People made fun of her. Being a woman, they called her names. And you can't imagine I've read the original papers that have come in Paris, accused her of being a harlot and woman without character. Every possible accusation a man can make on a woman was made. And amazingly, with 2 Nobel Prizes, the great academy, French Academy, I have belonged to it for many years now. I don't know why they didn't elect her as a member of the French Academy. That is the history of women, how they have suffered in science. She never became member of the Academy of Sciences. Anyway, leave that aside. Now, I'll close this very soon, just to remind you of great things happening in science. I thought with this 1912, just a year after atomic structure, remember? This young boy, he was again 22 years old. He was walking around in Wax in Cambridge and solved the first crystal structure on Earth. I hope some of you have read the first paper in Nature on zinc sulfide structure. It's a fantastic paper. How did that young boy solve the structure at that time? Crystallography is unbelievable, fantastic. And of course, he also shared a Nobel Prize with his father. That is a different story. But this again, these are all the important. As we did celebrate, I told you, 2011 as the International Year of Chemistry. Well, however, if you take that international year and go back to the year when atomic structure was made, that 1 century was very important. X-rays were discovered only in 1911. Radioactivity had just been discovered. Noble gases, well, not much known. Atomic structure just discovered 100 years earlier. Chemical bond was not known. That was only in 1916. Diffraction just discovered. Quantum mechanics was unknown. In fact, so when atomic structure was got to be known, people knew nothing about quantum mechanics, quantum chemistry, and so on. So I just want you to remember that many things that we take for granted today were not known when the structure of the atom was discovered. Well, now coming back to chemistry, what about chemistry? Chemistry actually made a beginning in 1794. 1794 is a very important year in the history of the world because that is when the French Revolution occurred. That 1794, Lavoisier, he passed away, but he is considered to be father of chemistry because he is the one who gave conservation. He is the one who gave the idea of conservation of mass, very important idea of a composition. Till then, even water was not considered to be a compound; it was considered to be an element. Nobody knew what water was, and he's the one who showed air was oxygen, nitrogen. For those who may not remember, the story of oxygen itself is very interesting. Who discovered oxygen? But the reason we give credit to Lavoisier is he took all kinds of research done by Priestley, Scheele, all put together and made a story out of it. So putting it all together, some of us give credit to Lavoisier for oxygen, but we need not, but he was one of the discoverers. He did a lot of work on combustion and so on. Of course, unfortunately, the 1794 was the French Revolution, and in the French Revolution, they cut off heads of everyone that was close to the king and the queen. He was very close to the king and the queen, and unfortunately, his head was guillotined. And this is the Lavoisier of that time. Well, he is the one who said, what is chemistry? Chemistry did not exist as a subject till Lavoisier. For those who remember, physics started exactly 100 years earlier. Newton was responsible for that. Around 1680, 1690, about a century earlier, physics started. But either chemistry was part of physics or natural philosophy, or most of the time it was part of medicine. Most chemists in Germany were medical doctors, amazingly, historically, for a reason, for whatever reason. Now, this is Lavoisier, whose head was guillotined, and this is 1794. Since Rudram Narasimha is here, being a local pride, I will take very important year in our history of the state, old Mysore state. That is when Tipu Sultan started. The third battle of Mysore was the year after that, when British defeated Tipu Sultan. Otherwise, British wouldn't have entered this country. Tipu Sultan, if he had won this third battle of Mysore. Anyway, that is the same year, 1794, 1795. Well, just you see, the interesting thing is, just around that time, just after Lavoisier, in 1803, about 10 years later, Dalton gave the idea of an atom. And this is very important to remember for chemists. Atom was an idea of chemists. Physicists, in fact, did not approve the idea of an atom for a very long time. They thought everything was the energy fields, this and so on. But they never said there was something called an atom. And it was Dalton who gave the idea of an atom. I'm showing his picture. For those who may not remember, in 2003, we celebrated the 200th anniversary of Dalton. Many journals, special issues, but I myself wrote some special articles for those issues for Dalton by 200th year of Dalton. And then you see the science was going on even in 19th century. Here is the great personality of the 19th century. I have to show him because before chemistry became so well organized, this man did so much chemistry, it is unbelievable. This is till about 1867, he died in 1867. Much earlier he had stopped his research. As you know his history, he started as a very poor boy working in a bookbinder shop. He had to do that because his father passed away. He had no money, he had to support his mother, so he quit studying after 3 years of schooling. And that, of course, that young boy started reading books on electricity and so on. He had read the book by Voltas when he was binding books, electricity and all. He was very carried by the electricity, Voltas pile and all that. It accidentally attended, as you know, 3 lectures by Sir Humphrey Davy. Those 3 lectures excited him so much, he wrote all the lectures beautifully in a book and went back to Humphrey Davy, presented it to him, look, here are 3 lectures given by you, and then of course asked him, can you give me a job? Because as all good directors and professors, he said, no, there's no vacancy, I'm sorry, he said, and sent him away. And it's amazing, fortunately for Faraday, this is absolutely, everything is luck in life. That's why Rutherford, luck to be in Cambridge. Faraday, just accident, that boy who was cleaning in the lab, runs away from Davy's lab. And he said, well, why don't you call that Faraday and let him be the cleaner in this lab? His first job was actually laboratory attender in Humphrey Davy's lab. And the real job he was called the chief bottle washer. He used to wash all the glassware in his laboratory. That is how he started his career, started doing experiments, learning new things, went with Davy all over Europe and became a fantastic experimentalist later. The number of things he did, every school child knows laws of electrolysis. You will all believe it is nothing but, imagine, he did electrolysis and explained electrolysis before the electron was known. See, unfortunately our teachers don't teach properly. In school textbook, everyone shows electron going, as if electron was not there, electrolysis was discovered. I think we should teach the way Faraday did it. Then say what we see today and so on. But Faraday did this before that. It's all before, in 1830, long ago in 19th century, liquefaction of gases, catalysis. He discovered benzene. This organic chemist would have given a Nobel Prize for him for that. Magnetism, of course, magnetism is fantastic. Magnetic lines of force. The Faraday rotation. I keep telling people that even today, to do a good experiment at Faraday rotation, I bet you I give you any one of you, including physicists, many of you here, to set up that in 1 week. You won't do it. I remember my old friend Ramaseshan's PhD thesis was Faraday rotation in the institute. C.V. Raman asked him to do Faraday rotation or something. I mean, he could never reproduce the results, he used to tell me, because he took the wrong compounds to work on. That was a mistake, but that doesn't matter. But anyway, it's a very difficult experiment. These are all the difficult experiments. Most important contribution, of course, was discovery of electricity. And the famous story of his discovery. He's telling the finance minister, principal chancellor of the exchequer, what is your value? What is the value of this work? This famous answer: someday you will tax it, and I think we are still being taxed. The most important idea in modern 20th or 21st century parlance that people credit him with is none of these, but the idea of unification of forces. He was the first one to talk of unification of forces. I hope you all know that. I'll come back to this towards the end of my lecture to remind you of this thing. And because there is some relationship at that time I would like to point out. Okay, now come back to history. Now I come to 19th century, 1830, Faraday's great year. I hope you all know, since all our students are working very hard, I want to see how Faraday worked. Faraday never took a holiday. It was the famous story of 1833, that's very famous thing. I've checked it. You can see all the books in London, they're all kept, all the books here. Beautiful handwriting. He wrote everything, he did it every day. He said 24th December 1833, some experiments and electrolysis or whatever. 26th he writes the next experiment. 1 day missing, 25th because it was Christmas Day. He didn't work 1 day. It's amazing. Okay. Now I'll come back to 19th century. That is when chemistry started. You see, remember, by that time Lavoisier had already told what chemistry was. Then you see, these are all the names. Berzelius, great physical. The reason I'm mentioning Berzelius is, He was the first one to think of how to explain a compound. Why do atoms form molecules? He was the first one to think of it. He gave the so-called electrical theory, completely wrong. At least the first attempt in the history of chemistry of how to explain a molecule or a compound was Berzelius. Then came isomerism and so on. And the greatest genius in 1858, Kekulé, I think the valence of an atom. Carbon has a valence of 4. Even today, I tell you, you make a fundamental discovery of that kind, which changed chemistry completely. He was the first structural organic chemist. He is the one by deduction, he is the one who started introducing the idea of a single bond, double bond, triple bond. Nothing of electron was known. Don't forget, still electron was not used. It is all 1858. No electron yet. So, it is all based on valence counting and so on. Kekulé was a genius. And then, of course, at the same time, towards the end of the 19th century, early 20th century, was Mendeleev. Came from a very poor family. He is a, I don't know if you know his story. His mother can't educate him, very poor. So but he wanted to give him a good education. To give good education, she said she should go to Moscow. They were from Siberia. They didn't know how to go there. They all put everything in a cart. They walk all the way from Siberia to Moscow. 1,500 or whatever by walk. It's an unbelievable history in the history of chemistry, history of science. You hear stories of this kind. And he comes from there. He won't be shaved, by the way, the beard once a year. You know that one. That is a very interesting beard. He used to go longer and longer until he cut it once a year, I think. I'm not even sure of that. Okay. Mendeleev. He's a very interesting story. He discovered the idea of periodicity. I won't show what periodic table he gave. You all know that. But unfortunately, in 1907, 1906, in fact, I have seen the original thing about this, by the way. Many of you may not know that. Actually, the Nobel Committee decides he should get the Nobel Prize. Unfortunately, by that time, in those days, French people and all are very big, very influential. French, British, they would go to the Nobel Committee, pressurize them, and they said, don't give this guy who has discovered fluorine, Moissan, from France, because he is dying, he is about to die. Before he dies, let him get the Nobel Prize. So they give to Moissan. And 1907, they wanted to give him. By that time, Mendeleev also dies. So I always advise young people, if you want to get a Nobel Prize, please don't die soon. Live as long as you can. Certainly not a year before getting the Nobel Prize, okay? All right. Coming back to the modern history, modern chemistry is about 200 years old, I said. Well, but that is not completely correct. You look at the elements, the first century had only 7 elements. That is why when people tell me they made planes in India 5,000 years ago, I don't know what to say. There is no titanium, there is no aluminum, there is not even steel. I just don't know what to say. Plus you draw your own conclusions about that. 16th century, 10 elements were known. And this, I don't know. Jatinder, please correct us. There are 23 elements. Lavoisier wrote a table, he wrote 23 elements in it. And now that is chemistry started with 23 elements in the 18th century and end of 18th century. But today, of course, we're 117. You want to correct it? Well, it includes my guru, Seaborg, a great man. The reason I show him is Seaborg is because he was the one who, at the pastime, made plutonium. I hope you all know the importance of plutonium. Otherwise, there will be another lecture. So, plutonium is an unbelievable discovery in the history. Of course, he got a Nobel Prize for that. And this is the periodic table that today we have from Mendeleev. I think this is something I wrote when I gave a lecture in the Swedish, there was a Swedish Academy of Sciences symposium. I gave a lecture some time ago. I said that this is the greatest table human beings have made. For one table, if you pick, I think there is nothing more important. It contains all information about all the possible things that one can do with elements. Even today, this table is something I use on a regular basis. If not boron, how to eliminate boron, why not carbon? Beautiful. This is a periodic table of today. Now, coming back to 20th century, what about chemistry? Well, if you take organic chemists, 3 organic chemists stand out in the early 20th century. The first Nobel Prize in organic chemistry was given to Emil Fischer. Then, of course, Grignard reaction and Willstatter. I hope you all know Fischer. He did fantastic things. Fischer is known for Fischer reaction, Fischer models. Fischer's name is known in so many things in organic chemistry. He was an unusual person. He would crystallize all sugars. And I always tell the story, even today, it's impossible to crystallize sugars. I think at least any organic chemist in our department can't do it. I don't know what others. But you put sugar in water and get back the crystal, not easy. But he could do that. And the story is, the joke goes, that is mainly because of his beard. And he would take the solution and shake his beard like that. And apparently that beard had all the great nuclei of all possible chemicals, and which would crystallize anything you couldn't do otherwise. That's a joke about him. He was a great teacher. Emil Fischer and even Willstatter, many of the big names I mentioned, Van Toff, all these people are students of Kekulé. Kekulé was the great teacher. Unfortunately, Kekulé, the first structural organic chemist who said the valence of carbon was 4, and of course he also gave the structure of benzene, he couldn't get the Nobel Prize. There was no Nobel Prize at that time. The Nobel Prize came, I hope you all know, in 1901, the first year of the 20th century. Because Willstatter is another very important story. I always shown right about cyclooctatetraene, how he gave that structure even today. There was no X-rays, there was no spectroscopy. How did he give the right structure of that? I think it is fantastic. How did he, after all, we knew benzene structure by that time. You would expect him to repeat the same thing, like a nice planar 8-membered ring. No, not him. He gave the correct structure. But more important, he is the one who showed chlorophyll has magnesium as integral part of it. He did many things on natural products. Willstatter was unbelievable. His story was fantastic. Willstatter, around the same time as Haber, was director of the Kaiser Wilhelm Institute in Berlin. And Willstatter got very disillusioned when the Nazis told him you can't have any Jews in this lab. He himself, being a Jew, just ran away and left Germany and went away to Switzerland. Today I'm not going to talk about the story of Haber. That is another story. He continued and died in misery at the end. But Willstatter, this is his tradition of chemistry that was continued much later by people like Robert Robinson and Woodward. They are all followers of the Willstatter tradition of organic chemistry. If I have time, I will mention that. Physical chemist, Van Toff, another student of Kekulé. He is the one, you see, even today, I have asked this question in every comprehensive examination of our department. How do you know methane is tetrahedral? Nobody answers it right, our student. And there was no X-rays, no spectroscopy, right? No quantum mechanics. So, he is the one who showed tetrahedral nature of the valence of carbon. 4 valence of carbon directed towards the 4 corners of a tetrahedral. What a great. He also first one who started using what you might call mathematics those days. It's not mathematics, using equations to describe behavior of material. He was the first one to write, for example, osmotic pressure was the same as ideal gas law. The rate of reaction, dC by dt, is minus C, e to whatever, that famous, e to the power of minus kT, whatever it is. So all these things were done by Van Toff. He was the first Nobel laureate in chemistry, 1901. And people laughed at him, but those who are physical chemists, let me tell you, all the chemists said, who is this crazy guy? We do all the experiments and he comes out with an equation. And for that you give him a Nobel Prize. And he never did any original discovery. There is some truth in that, except that he done already tetrahedral carbon, that is original. But rest of it is all explained what is already done by measurements by others. But subject physical chemistry was just born, as you can see. He is one of the fathers of physical chemistry, along with this man, Oswald. Oswald was the greatest teacher of physical chemistry. Almost every physical chemist on earth at that time worked with him. Everybody. Nearly 40 professors of United States, Richards, Noyce, G.N. Lewis, mention anybody, they all did postdoctoral work or PhD work under Ostwald. And I'll come back to Ostwald later. And this is Arrhenius, you see. Arrhenius is a big guy, as you can see. Arrhenius is another story, another great physical chemist, but you must know his story. He wrote a thesis on electronic theory of dissociation. This is another thing which is before the discovery of the electron. Entire electronic theory of dissociation was done, did not know electron was there. He wrote this, went on writing this big thesis, became this big, 1,500 or so pages, I believe. He had to take so many copies for the examination, he just couldn't carry them because it was so heavy. But of course the examiners looked at it and said, we'll flunk him, we'll not pass him. So they didn't pass him, therefore what they did was consolation PhD they gave. The consolation PhD in Sweden those days meant you could not teach, neither can you work in an industrial laboratory. So what does he do? Here is a PhD which is a bogus degree. He says, no, you no use, you can't get a job, you can't do anything. So he was in a miserable condition. Then he sends his thesis to Oswald, the great father of physical chemistry. And can you do something? Oswald immediately says, come back and join my lab. I won't give you any money, but you can work here. So he works for 8 years in that lab of Oswald was a very great man. Very great man. And anyway, that is where Arrhenius went. At the same time as Nernst, he is the first theoretical chemist of the world. For those who are theoreticians here, first he is the one who gave the first form of the third law of thermodynamics, Nernst heat theorem, Nernst equations. You all know Nernst. He got a Nobel Prize in 1920. Nernst and he were very good friends, you see. They were both in Oswald's lab. They would go drinking a lot. They both drank a lot. They would go around and they had good fun. Until Nernst went away somewhere as a professor, and Arrhenius eventually Sweden gives him a professorship after many years. They think he is actually a genius. He should not be treated the way they did. And they go, once he visits, Arrhenius visits Nernst, and Nernst by that time had done this Nernst lamp. I hope you know the history of lamps. He made this lamp and he had put everywhere. Just as Arrhenius came, big guy, and the lamps all failed. He gives a big lamp, he says, you and your lamps. And being a real Prussian, German, Nernst never excused him. He said, you get out of here. He never talked to him again. And they became such close friends. After this one incident, became enemies forever. Arrhenius, in fact, delays his Nobel Prize as much as he can because he becomes very powerful in the Nobel Committee, Nobel Foundation, and you can see he had to wait. He himself got in 1903, he had to wait for 17 years to get the Nobel Prize because Arrhenius wouldn't allow him to get it so fast. Arrhenius is very powerful, you see. So these are all stories of that kind. What about inorganic chemists? Ramsay, 1904, very important man for the history of Bangalore, Indian Institute of Science. It is Ramsay who made the noble gases, and his student Travers was our first director in Indian Institute of Science. Like people like Rutherford and myself, old timers in IISc, will never forget IISc, and those who don't belong to it also is historically very important. See, it's 1904. Around that time, the idea of establishing IISc was there, and everybody said no. The Viceroy said no. Everybody said there is no need for a research institute in India. And then you see, fortunately, the Viceroy decides to refer it to the Royal Society. The Royal Society appointed a committee with Ramsay as the chairman. It is the Ramsay committee report, let there be a research institute in India. And of course, later it came to Bangalore. So we, poor Ramsay, great guy, who gave this institute at that time. Well, moving on, you remember I told you the guy who died in 1907 for having discovered, he is another inorganic chemist. His were noble gases, and this is of course one of the greatest inorganic chemists, Werner. Werner was the first one who applied the principles that Kekulé had in organic chemistry to inorganic compounds, to nitrogen compounds. And of course, the only problem with Werner was he had excessive drinking. He drank a lot, hanging around on the bars and tough life. And of course, died at a very young age, as you can see, very young age, hardly 53. But he is a great chemist. He got a Nobel Prize in 1913. Werner theory of coordination chemistry, I hope you all know. Well, chemistry is synthesis, making things. Don't forget the first compound made was only urea. Simple compound, as simple as you can get. And that was made by Wohler. I hope you all know. Every chemist on earth opposed it. He says you cannot have discovered it because the belief then was all organic compounds can only be made by nature. Men, human beings cannot make it. only, because you need divine power to do organic compounds, right? Ordinary humans can't do it. There's a big faith in religion also entered there a little bit. If you read the original literature, all the clergymen, everyone is against his discovery of urea, except Berzelius. Berzelius is a very great Swedish chemist. He was a fantastic man. He was a great patron. He said, no, he's correct. He's the one who supported him. And that is Wohler. And just to give you one molecule here, Woodward's, Eschen-Moser Woodward's, B12. Now, of course, all kinds of molecules are made. Now, synthesis is no longer a challenge. Organic chemists here don't get angry, but the people don't give money for synthesis anymore, because you can get anyone to make synthesize anything. Though early days, of course, in my days, I come from days when synthesis was the prime thing in chemistry, organic chemistry. Synthetic organic chemistry ruled chemistry, and not now, not anymore. In fact, you don't find professors of synthetic organic chemistry in any major university in the world today, like Cambridge, Harvard, Berkeley, anywhere. However, those who do synthesis do other things, apply to various purposes, and there is a lot of very good chemistry there. And I just want to make sure, correct myself there. This is those who have got to Göttingen. You see in the center of Göttingen, you see a statue of Wohler, and this is the first man who made a compound. And this I showed you in the 20th century chemistry. If I want to pick one name only for synthetic organic chemistry, I could have picked Robinson, but I think Woodward was even greater than Robinson. Robinson went in the tradition of Willstatter, making all kinds of natural compounds. And Woodward did the same thing. Woodward and Robinson competed a lot. Woodward, Robinson being a typical Englishman, Sir Robert Robinson, president of the Royal Society, had a very poor opinion of Americans. And Woodward came from MIT, you see, and then in Harvard, and he always looked down on that. Once they both met in a restaurant in New York. They were both working on the structure of strychnine. I hope you all know what strychnine is, quinine, strychnine. And then he asked Woodward, what is the structure of strychnine according to you? He takes the tablecloth and writes the structure of what he thinks is the correct structure. And he says, rubbish, Robinson said. He went away. A month later in Nature, there was a letter by Robinson giving the structure of Woodward as the correct structure. So this is a well-known, I don't call it whatever it is, there is a story. That's the real thing that happened. But why, how, and all, I won't talk about that. They are both great men. The modern chemistry really started, according to me, in 1916. That is when the idea of a chemical bond came. That is when we said that putting two electrons between two atoms, electron sharing. That idea was given by G.N. Lewis, taken forward by Linus Pauling, and the beginning of modern chemistry started with that, and that is the great G.N. Lewis who started that. G.N. Lewis, of course, when he gave this idea, of course, for those who know, historically, 1 minute extra, I didn't want to tell all this. When he was just after his PhD in Harvard, he was an instructor. Just then electron was discovered, right, 1897. So in 1991, he wrote a famous paper called Electrons and Molecules, and took it to the head of the department, Richards, who is his guide, PhD guide. He took the paper and threw it like that. It's rubbish. For everything he would call it rubbish. And Lewis got so upset. He took away the paper, didn't publish it. And that paper, of course, took a different form, eventually published in 1916. And he got so sick and tired, he left Harvard after that and went over to Philippines for 2 years. And even there he published 3 papers from Philippines, where he was working on the Standards Institution or some stupid place there. But amazing thing is he picked up the discovery, discovered the beauty and the wonderful pleasure you get by smoking cigars. If you have not smoked cigars, I can tell you that you don't know what you mean. They're fantastic. But I stopped smoking, but when I smoked, I really enjoyed it. And in Berkeley, he used to smoke 23 to 24 cigars a day. His chemistry department was known, because by the time I went to Berkeley, he had already died. The smell of cigar, we knew where exactly chemistry department was. So that was Lewis. And I want to do, it is young Pauling in Caltech as an assistant professor with his wife. I think he was about 25, 26 years old. He had just come after postdoctoral work in Germany with Sommerfeld. Sommerfeld is again another father of all chemists, physicists. Heisenberg, Pauling, mention any name in physics, they were all his students, and Pauling also was his postdoc. And then he comes back and he was an assistant professor. In fact, he was actually wrote first, they said, you'll be made assistant professor of physics and chemistry, but Millikan, who was then the president of Caltech, didn't like him. And he said, no, only assistant professor of chemistry, no physics. And he said, no, he didn't know whether to take up the job or not, but he took up the job. Good for Caltech, because Berkeley had also offered him a job. What did Lewis do? It's very important for you, everyone to know in history of chemistry. He did not get the Nobel Prize, though he contributed more than any other chemist, according to me, in terms of ideas. The idea of a chemical bond was one. He is the first one to bring thermodynamics to chemistry, whether it is free energy, third law of entropy, third law of thermodynamics, and he is the first book he wrote, Outlines of a New System of Thermodynamics. For those who want to read good English in scientific literature, the preface to this book is the English of that book, unparalleled. It's a beautiful, his style of writing. He was a very poor speaker, but he wrote very well. There is one problem. In fact, that is why our young professors are always traveling nowadays. But those days he never went anywhere. That is one reason probably that affected him in many ways. He did electrochemistry, idea of activity, ionic strength. He is the one who gave Lewis acids, Lewis bases. In fact, the PhD thesis of Glenn Seaborg was on Lewis acids and Lewis bases. He was the one when heavy hydrogen was discovered, made to make heavy water, making in the lab and properties, applications. First photochemist, triplet state, major ideas in spectroscopy, and of course, there are a whole bunch of things he did. It's unbelievable. And this is the first paper he wrote, and how he wrote. Instead of we wrote circles and so on, he wrote cubes instead of circles. That's all the difference. Made a bond, chlorine molecule, oxygen with a double bond. I hope you can see. This is how he wrote the first paper on sharing of electrons. And this is very important. Nernst gave this third law, which is then known as the Nernst heat theorem. Nernst heat theorem just said G is equal to H at T equal to 0. That's obviously wrong. He corrected him and said it is only true. G, if not G, we can call it F. F is I am a Lewis man, so I use Lewis notation. Gibbs notation will be G. Lewis F is equal to H, so F is equal to H at 0, provided S equal to 0, you have to say, otherwise. And that is when he verified third law of thermodynamics in big way in Berkeley. That was a major thing, verification of third law of thermodynamics. And that is also Lewis's thing. And Lewis doing experiments, he was a very great experimentalist. But he was one of the fantastic theoreticians of that time. He even published papers in relativity, all kinds of things he used to do. But towards the end he stopped it, did only physical chemistry, or what you might call new ideas in chemistry rather than anything else. He was nominated for the Nobel Prize 20 or 25 times. Towards the end, after chemical bond got rejected as not being important for chemistry. Thermodynamics was considered not important, ignored. Then ionic strength, electrochemistry got ignored. Each time he got ignored at that time, he started a new field. Then he started photochemistry. He is unbelievable. It's the way he did science. And the last day of Lewis was March 23, 1946. It is the greatest death in history of chemistry. 1946, March 23. I will never forget the date, because he told one of my very close friends, who was a professor at Florida, many of you spectroscopists here will know, Michael Kasha. Michael was his last PhD student. Michael went to see him in the morning. He had a typical style of doing. Everything was like Glenn Seaborg always said, Ram, the way he used to tell me, Glenn admired him. He got his PhD under him. He is the one who put him on artificial elements, don't forget. He told him to make artificial elements, and with Gibson. And he used to tell him, hey, Glenn, come and see me at 8 o'clock, let us write a paper, he would say. Okay, I'll see you in the morning at 8. No, not morning, tonight. He would sit at 8 in the morning, now till 1 in the morning, writing paper. He would dictate the paper. Bang, he was a genius par excellence, I mean, not just a genius. And same with, I've heard this story innumerable times, particularly from my friend Kasha, Michael Kasha. I hope you all know who Kasha is, otherwise there will be another seminar. Michael, he retired. He probably is dead now, recently he died, I think. He was a about 7, 8 years older than me. Michael went there and he told, Lewis told him, I wanted to do an experiment, run an experiment of a spectrum in a liquid of high dielectric constant. Those days we did not have dimethyl formamide, dimethyl sulfoxide. Which is that liquid? He said, do liquid experiment in liquid HCl, liquid hydrochloric acid. He said, no, I'm not going to make it. It's such a poison. How can I make that? Okay, you go to have lunch and I will make it for you. You can use it and do that. So when he came back, he found a bulb of liquid HCl on the vacuum line, one broken bulb on the table, on a lab table. And there was Lewis sitting in a chair, dead. And the question is whether Lewis committed suicide or it is an accident. Nobody knows. In fact, I have talked to Hildebrand, my own guru, was also his student. All these people, in fact, my guru, sir, always used to tell me, Ram, he was such a brilliant man. He would make an accident, make a suicide look like an accident. He was like that. Of course, there are many stories that morning he saw a Langmuir in the faculty club. He hated Langmuir. Because Langmuir cheated him in science. Langmuir got Nobel Prize, of course. Langmuir was a brilliant man, no doubt, except that after Lewis' chemical bond came, Langmuir started publishing paper in JNCASR, the idea of octet theory. Unfortunately, every textbook in chemistry, to my shame, even today calls it Langmuir octet. It is disgusting. Historically, what he did, he called it 8, he didn't call it octet. 8 is octet. But he wrote this when this happened, the famous correspondence in Journal of American Chemical Society. Lewis writes a letter to the editor of JNCASR. This man continues to publish. There is no new idea which is not in my several papers on chemical bond. Please read that. And amazingly, the editor of JNCASR writes back, I'm very sorry, I will not publish any more papers of Langmuir. And Langmuir, after finding that, writes a beautiful, they were all gentlemen. I apologize. I will not do any more work in this field. Please excuse me for this. They never met after that. Lewis never excused him. And that day, apparently, Langmuir had come to give a seminar in Berkeley. That is the story. And he saw him in a faculty club. That probably got him all worked up. And whether he took his life out of that, I don't know. But Langmuir got a Nobel Prize. He was working in General Electric, as you know, the famous Langmuir adsorption and all that. So he died. 1954, the Nobel Prize was given for the chemical bond. I'll never forget, to a great guru of mine, Linus Pauling. And Linus Pauling, he should have shared it with G. and Lewis long before. That was not the case. But Lewis was not there to receive it in 1954. He had died in 46. To me, that is the greatest death in science, one of the greatest deaths. Where a man who has done so much got ignored. In that way. Just, of course, Linus Pauling was similar. He was treated badly too because of other reasons. Okay. Chemistry after the chemical bond. I come from this season. I was born in 1934, but 17 years later, 1950 onwards, I got into this race of understanding the chemical bond. Everything was spectroscopy, molecular structure, mechanisms, new methods of doing structural determination. I come from this season, and for those who may not know, it was only when I went to United States in 1954, spectroscopy was just becoming chemistry. Everybody was doing infrared, Raman. I also did diffraction and so on. And it's a very, very important period of structure. Structure dominated and bonding dominated chemistry. And of course, 1951 also important year in history of chemistry, because that is when Linus Pauling discovered the alpha helical structure of proteins, and this is birth of molecular biology. In fact, many biologists don't give him as much credit as they should, but Crick, if you have seen, Crick says, I consider him to be not at least one of the fathers of molecular biology, because of many things he did, particularly the alpha helix. This is the Linus Pauling when he did the alpha helix. In fact, soon after that, in 1954, after his Nobel Prize came in October. Just before that, he was supposed to come to India. He couldn't come because they had withdrawn the passport. Therefore, he was not to have a passport because he was considered a security risk by American government because of his views on atmospheric testing of nuclear weapons. which we all agree today, everyone agrees today, not then. But anyway, he couldn't come. In fact, I went to see him because he came to Science Congress 54, supposed to come in Hyderabad. I went all the way, but there was no Linus Pauling, but a year later I saw him in the United States. But he got the Nobel Prize 6 months later. After his Nobel Prize, he got the passport back. Chemistry at that time, in fact, I used to teach in Berkeley, in Kanpur. Chemistry is three things. I don't know, Ela or somebody who was a student there will remember. Chemistry is structure, synthesis, and dynamics, and so on. And that was the whole thing. But unfortunately or fortunately for chemistry, many things happened after 70. Biology particularly made big inroads to chemistry. Advanced materials, equal proportion, it made advanced big inroads to chemistry. Of course, since then, I'm giving you examples, superconductivity, new carbon forms, nanomaterials. A number of things happened which made advanced materials a big thing, entire area of nanomaterials. So chemistry became a different type of subject. And I just want to mention, I'll come back to that later. And many new ideas came. The idea of supramolecular chemistry, other than strong covalent bonds, you can have weak bonds that give you stable systems, molecules. I don't know why I gave my own. This is Whiteside's who had predicted this molecule, and we determined structure here in 2000. I just thought I would give an example of supramolecular chemistry with lots of hydrogen bonds. I show this not because of our work, but superconductivity played a very big role in the history of chemistry, because in December 8, 1986, a first superconductor which was superconducting above 23 Kelvin. Till then 23 Kelvin was the upper limit. It was 35 Kelvin, lanthanum, strontium, cobalt, copper oxide. And then, everybody wanted to make a superconductor which is at liquid nitrogen temperature. Everything was 35 Kelvin liquid helium. Liquid nitrogen is above 77 K. So we also tried in Bangalore. And of course, this is our paper in March 1987 in Nature. This is the 123 compound, the first liquid nitrogen superconductor. The reason I'm showing superconductivity as an important part of chemistry, if you see the US National Academy of Sciences, along with National Academy of Engineering, have published a very famous report on materials and condensed matter science, where we are. There they say, the role of chemistry in the study of materials and solids really changed, in fact made gave an importance to chemistry after discovery of superconductivity. Till then, they ignored chemistry. Chemists had a bunch of fools making compounds, but then without here, they made very crucial contribution to superconductivity. And that is what it says, and I agree with that. And there are many other things that have happened. Fullerenes came, my friend Harry Kroto and Smalley, they discovered it. Unfortunately, Harry Kroto passed away a few months ago. The 6-membered ring, and rather C60 with 6-membered rings and 5-membered rings, and C70. This is another major discovery. Then came nanotubes, 1990, again very important. There's so many things that have happened. All kinds of nanostructures, all kinds of shapes, all kinds of materials people start making at, and all kinds of applications for simple materials. And now, and because of this, what happened was, National Academy of Sciences wrote a new report in 2003 called Beyond the Molecular Frontier. Till now I said bonds and molecules are the basis of chemistry, but it's no longer the case according to National Academy of Sciences, which in this report says chemists no longer worry about just molecules, they worry about living systems, therapies, optimization as in biological systems, well, new co-synthesis, that means something else here, self-assembly, complex chemistry. The complex chemistry means not chemistry of complexes, chemistry of the earth, sea and atmosphere, very difficult area, materials by design, and of course computation. Computation, of course, has become so powerful today, I don't have to say. So this kind of chemistry took birth somewhere in the last maybe 15 years or something, 10 years, and that is what we are seeing today. And of course, just to remind you, just to show how it has happened, less than 10 years since the discovery of graphene was made, then it is easy to make it because by simple micromechanical cleavage, that single layer of graphene, the properties are fantastic, and you can characterize by various means. Today we have techniques, all kinds of microscopies available. We can do all characterize these nanomaterials, And we know this greatness of graphene came because of the electronic properties, zero gap material, unusual quantum Hall effect, a number of things of this kind. And the minute carbon came, people started working on why not inorganic type of graphene type derivatives, inorganic layered compounds, inorganic fullerenes. My friend Tene in Weizmann Institute, this is of course, one is here, this is a Bangalore fullerene type structure. Lots of nanotubes of all kinds that made in many places, particularly again in Bangalore, sulfides, chalcogenides, nitrides. Today, of course, you can make nanotubes of anything. And then inorganic nanosheets, you can make MOS2 just like graphene. You can see one single layer sheet, you can make that, and so on. And now today, one of the main concerns is, of course, energy and environment. People are worried about so many things: hydrogen, solar, fuel cell, batteries, catalysis, and also emission control. These are some of the aspects where chemists are interested in all that. Hydrogen as a new fuel, as important fuel, fuel cell batteries, and so on. And of course, making hydrogen, and also, if possible, do other things like reduction of carbon dioxide. Well, I always show this slide just to remind you, as early as 1874, solar energy had been shown as important, or hydrogen has been also shown important. Sir, I have not shown the solar energy slide where Henry Ford says, why is it man not using sun? There's so much sun energy. That is a beautiful thing. So long ago. I'm talking about long ago, Henry Ford writing that. Today I took that out because it's getting late. This is something from Jules Verne, The Mysterious Island. And what will they burn instead of coal? Asked Pencroft. Water, replied Harding. But water decomposed to its primitive elements. Yes, my friends, I believe that water will one day be employed as fuel. That hydrogen and oxygen, which constitute it, will furnish an inexhaustible source of heat and light. Water will be the coal of the future. Written in 1874. It is very interesting. Okay. Hydrogen, of course, we can make by various means: water splitting, thermal semiconductor nanostructures. A lot of progress is there, where photosynthesis in nature can be more or less imitated in the laboratory by using similar inorganic structures to catalyze oxidation of water. You can also do reduction of water by using the right material with the right band gap, and so on. You can use materials where you can reduce protons to hydrogen by a number of methods, and so on. So today we have been interested in energy, environment, and so on. Well, I would like to end my lecture. I think I am a great follower of Michael Faraday. Michael Faraday said nobody has the right to give a lecture for more than 1 hour to an audience. So I must hold on to that. It's almost time. I want to end with a few comments. The beauty of chemistry to me is not because we are doing something interesting, exciting, but I enjoy the knowing where we all come from. Enjoy knowing where ideas came from in chemistry. And I will never forget all these great men. In fact, when I think of anything I do now, I always try to relate to the earlier ideas that are responsible for today's ideas. In fact, I show this one as a good example. In fact, in Einstein's room, they had 3 photographs. One was Newton, the other was Faraday, and then Maxwell. And Einstein said, the idea of unification was actually given by Faraday. And Maxwell wrote the mathematical formula. And you know what, I hope you all read Maxwell's book. It was the textbook for us in Berkeley when I took my physics course in America long ago, electrodynamics and all. There he says, Faraday is my guru. I have done nothing. I have just put some equation. The idea, it is all due to Faraday. That's what it is. I'll never forget that introduction by Maxwell. So that is the kind of thing about chemistry. The kind of feeling we have to our ancestors. Einstein gave a lot of respect to both these people as the people who originated the idea of unification of forces. To me, the same thing. Well, I did my master's thesis in India with Professor S.S. Joshi, who had a DSc from London. He was a student of Donnan. Donnan was a student of Ostwald. You see, Donnan, therefore, was my grandfather, and Ostwald was my great-grandfather. Well, then I go for a PhD. I work with a professor who was a student of Linus Pauling. I always considered Linus Pauling as my grandfather. But whenever I met him, I used to joke with him. He was a great man. When I got to know him rather well, after a year or two in America, where I determined two structures of molecules to verify his theory. And you see his third edition of the Nature of the Chemical Bond, both those structures have been cited by him. Linus was my grandma. But when I go to postdoc in Berkeley, I worked with a professor who was G.N. Lewis' student. So G.N. Lewis also is my grandfather. This feeling is not because they are grandfathers and grandfathers. We carry that legacy. If you are any good, you have some ideas like G.N. Lewis. If you are any good, work like G.N. Lewis. If you are very good, be like Pauling. That type of thing bothers me. I am not like Pauling. I am not a G.N. I will never be that. On the other hand, the fact that I belong to that family, I feel wonderful. I hope you all feel wonderful. You belong to the family of chemists. Chemistry is not a bad subject. Fantastic subject, fantastic history, fantastic stories. Unfortunately, we don't remember them. We don't cite them. We don't quote them. We don't really tell people about it. Chemistry, I am very proud to be a chemist. And don't be, I'm not a chemist, I'm doing biology. Hey, nothing. Chemistry. I'm sorry, here's the chemistry. I'm not doing, I'm doing actually theory, not really experiment. No, chemistry. I'm very proud to say I'm doing chemistry for the last 65 years. I'm very happy about 66 years, of which 59 years I've been a teacher in India. It's been a wonderful life. Chemistry has given me more than anything else gave me other than my wife. There are the two things I love, my chemistry and my wife. It's been a wonderful life. I don't think you can have a better life than doing chemistry in your life. I wish some of you enjoy what I'm saying and not enjoy what I said. Enjoy chemistry the way I have enjoyed. You won't find a better word. Good luck. God bless.